Hi, everyone. Welcome to Unleash the Potential of APIs with Azure API Management. So my name is 𝗦𝗲𝗀𝗀𝗶𝗫𝗬𝗫𝗀𝗀. I'm from the Azure API team as an engineer. And we have Julia and Bruce that are going to join us a little bit later. So this talk is really in two parts. So the first part, we're going to talk about the GenAI capabilities in Azure API Management. And for the second part, Julia and Bruce are going to show us API Center. So let's go ahead and talk about Azure API Management. So what is it? Azure API Management basically enables publishing, securing, and transforming APIs very efficiently for organizations. And it has a comprehensive set of features around security, analytics, policy, and basically being able to govern across multiple APIs. It has over 50 built-in policies already. Pretty much any sort of API management task that you want to do, there's likely an existing built-in policy for that. So at the end of the day, though, it functions as a secure gateway between your applications in the front end and your APIs in the back end. Now, over the past few days, we've been hearing a lot about platform shifts to AI. And assuming that's the case, like the previous platform shifts with web and mobile, you can pretty much say that every app will be reinvented with AI, and new apps will be built that weren't possible before. In Azure, the primary and the foundational services for this transformation are offered by Azure OpenAI. So they offer a set of latest and greatest models with GPT-4, the newer omni-channel models, GPT-4o, a set of generative image models, as well as a set of APIs and SDKs that enable you to program against these APIs using your favorite tech stack. They offer multiple pricing models, including pay-as-you-go, and including throughput units that are pre-provisions, PTUs. Tokens are a key concept when you talk about language models, so let me just spend a few seconds explaining what they are. Tokens are roughly, let's say, 1 or 2 tokens per words that go into a language model and come out as a prompt. They are used to measure resource consumption in language models. So if you want to find out how much you have to pay, tokens are involved. If you want to figure out what the capacity is of the service that you can use, also there's measures based on tokens, like tokens per minute. Now let's start with building a simple and single intelligent app. The basic steps are you go ahead and provision an OpenAI service deployment in the backend. You use the favorite tech stack SDK that they provide for your app to connect to it. Then what you do is you use, for authentication, they offer API keys that you have to share with your app. And at this point, you have a basic scenario working. What if you want to scale this, though? What if you want to go into multiple applications? What if you want to have multiple backends? We've heard from a lot of customers, even yesterday and the day before here, that they see fundamental challenges with this, and they want to be able to solve a few challenges, including things like having observability into the usage of resources in their models, so token tracking. They want to be able to sometimes use multiple backends, so sometimes for using multiple pricing models, a mix of PTUs and pay-as-you-go, or just having multiple models in multiple regions for availability. Sorry, I'm going to go back quickly. OK. So anyways, we're going to go through the functionalities that we're going to offer. And these are packaged as part of the GenAI capabilities for API management. And there are a set of features and policies. So we're going to start with the first policy that's going to be available that's going to be announced as generally available. This is the token metric policy. What this allows you to do is look at usage as the calls come into API management, and those are going to get logged as metrics into application insights. You see a policy here with dimensions. So you can assign custom dimensions on all the activities that are happening through APIM, and this allows you to solve issues like, for example, being able to accurately cross-charge across applications for usage, or just to get insights around how the application is used, how the resources are used, so you can make decisions as you go forward. We're also making available, generally available, the load balancer and circuit breaker functionality. So this functionality is not exclusive to GenAI. It applies to all APIs, but in this case, it's fairly useful for a lot of the issues that we've been hearing from our customers. So in a lot of cases, you want to use multiple backends. And a common case is having PTU as a capacity reserved for a baseline of your usage. And then on demand, as demand grows, you want to be able to fail over to a pay-as-you-go. This way you have full availability, but you're also optimizing on costs. The load balancer, it has a few other functionalities that enable you to customize based on duration, based on priority, and a few other things that help you solve a lot of other problems too. Authentication and authorization is sort of a bedrock of what APIM already has, and it applies to all APIs, but in this specific case, it allows you to use managed identity to connect to your backend. This way, there's no secrets that you're managing. On the front end, if you have multiple applications, the common model that APIM uses is called APIM subscriptions. This is different from Azure subscriptions, where there's a subscription key that you hand over to each of your apps. This way, you can manage access, and you can basically also measure how each application uses resources. You could use any of a few other ways of authenticating. So for example, you can use intra JWT tokens. We have a policy for cracking open JWT tokens and figuring out the user and either allowing or not allowing. So that's also possible. So another feature that we're announcing is generally available is token limits, token limit policy. This allows you to limit the amount of resources used by each of your applications. You can basically, if you see here, you can define a counter key using a policy. This is one of the very powerful things in APIM is a lot of policies can be modified with expressions like this one. So in this case, we're saying per app, but you could build expressions that could be per app, per user, whatever custom expressions that you want to use. And you have a tokens per minute value there that sets the limit. So this allows you to govern applications and make sure that they don't trample on each other and use up resources that stop the other one from functioning. We're also announcing a preview of semantic caching. Normal caching with APIs is done by using exact caches, sort of exact keys for caches. In language models, it's a little bit different because you have inputs coming in that are prompts, and you may have prompts that are not exactly the same. They're semantically similar. So we've added this functionality that uses Azure Cache for Redis Enterprise with the Redis search capability, which allows you to cache responses for requests, and then for lookup, you would have to search for it based on a similarity score. Here in the policy, you see 0.05. That determines how close one request has to be to another in order for the response of the first one to be looked up for the second one. And again, you can vary this by or partition this by subscription ID or other expressions. So let me actually show you all of these things in action. All right, we're seeing this, great. So here we are in API management. You have a set of APIs that you've cataloged. You can add more from your organization. With the new set of functionality that we have, now we have the ability to import a new API from an Azure OpenAI service. So I'm going to do that here. And using a specific name here, I'm going to add this URI here so that a lot of the common SDKs used with OpenAI would function. You see some options to add the policies that we talked about. So for example, a set of simple options for adding managed token consumptions, a set of options for tracking and being able to log that into application insights, and the ability to add common dimensions like subscription ID that we talked about. So once I've done this, go to the next step, and this is telling me that it's going to automatically enable managed identity, which we talked about. It enables a simple and secure way of connecting from APIM over to OpenAI. And in the baseline, we're using APIM subscription keys for the apps calling in. So let's create this. And you should be able to see this new one, fully configured with a set of operations that OpenAI provides and a set of policies that are pre-configured. So I'm going to quickly go to an existing API that we have that has these set slightly differently. For example, I'm going to start from the top. Authentication, managed identity. This is the policy that enables managed identity to the backend, to OpenAI. The second one is, again, what we talked about around token limiting. The counter key is subscription, meaning each application gets its own limit. And we have a limit of 10 here, which is very low, but for demo purposes, normally this would be higher. So here what I'm going to do is I'm going to run a few Python scripts to start 2 chat applications. This is the first one. This is the second one. Let's put these side by side just to drive home the point that these are separate applications. So these are on separate ports. These are using separate subscription ID keys. And on the first one, I can ask a question, what is Azure? It's going to return me a response. I'm going to ask a second question, what is APIM? And it's going to tell me you can't do this because there was a limit of 10. So that's taking effect for this app. Now, a separate app, if I do the same thing, I should be able to get the response back because these apps are isolated, and we can manage the resources used by each. And the other thing is they can't trample on top of each other. They're isolated. So that's token limit. I'm going to show you guys another feature called load balancer that we talked about. And for this, I'm executing a bicep import process, and I'll show you what the bicep contains. The bicep file contains resources around backends and load balancers. So you have 2 backends. One is a backend to a PTU. This is dedicated resources provisioned for you. once a response of 499 comes back, which is too many requests, the circuit breaker for this backend breaks, and the load balancer will switch. And within 15 seconds, it can come back. The other backend is pointed towards a pay-as-you-go backend, and your load balancer contains the two with a certain priority. So first the PTU, then the pay-as-you-go. So what happens is, first of all, I can quickly show you. Apologies, I'm just going to show you that the import was successful. And then what I'm going to show you is that these are the backends and load balancers that were imported. And if I were to run a Python script here, that's going to just hit API management with multiple requests one after another. What's going to happen is, as you can see, it's hitting first the PTU. It's using up the resources because we set it to a very low number, switches to the other region with the pay-as-you-go instance, and then back and forth after 15 seconds that we had set up on the resource. So now, if you remember the metrics policy that we configured a little while ago, we should be able to see the activity that we have done so far over here. So we're choosing total tokens as the name of the metric. We're using sum as the aggregation. And we see within the past 30 minutes, we've used up a set of tokens. Now, we should be able to split this based on the dimensions that we defined. And as you can see, we have a set of apps. We have the two apps that we were demoing first with the small number of tokens called. And then you have the third app, which was the one that was hitting the back end and it was switching. Okay, since we have a little bit of time, I think, right? I'm going to try and show you semantic caching also. So here I have another API set up with semantic caching. And let me actually make it so that you see this a little bit better. You have a pair of policies. You have a cache store policy down here, and you have a cache lookup policy up here. As we mentioned, there's a score threshold score that we're using here to make sure we're retrieving the right response. And we have a duration for the caching down here. So to use this, we're going to use test here and use the first chat completion API. The test console and API management, we can modify this or send it as is. We're sending a request, and we're tracing this just to be able to see the length of the request. So here you can see the response came back. But if you were to look at the trace, you should be able to see how long it took. This took around 2.5 seconds, which is fairly long. And if we were to send this again, but modify it slightly, again, we should be able to see the message. It's exactly the response, which is exactly the same. But if you trace it, you see that it's 100 milliseconds, so much faster. It was cached and it was retrieved. And to prove that, we can go down here. It's giving us exact information on finding the cache, the score that it calculated, and how it's within that threshold that we're talking about, so we can adjust the threshold based on what we see here. And the cache was hit. Okay. So that's it for what I had to show you guys. And Here's some resources where you can get started. Set of documentation, set of guides and samples. Just as a note that if you want to try this today, this is definitely available in our SKU v2 across all regions, and it will be available in all SKUs in all regions within the next few weeks. So with that, I can't wait for the questions at the end, and here's Julia.
Awesome. Hi, everyone. My name is Julia. I'm the PM on Azure API Center. And some of you might be asking yourself, well, what is Azure API Center, right? You came from an API management session. So Azure API Center is the newest service addition that Microsoft is offering part of their API platform portfolio. We are part of the broader API management platform system. We are a separate Azure service, though, and we are now, I'm very excited to announce this, we are now generally available. So what is Azure API Center, especially compared to API management? You might be finding yourself in this situation where you have different APIs managed, not managed, all across your organization. Some of these APIs might be in different API management instances because you have even multiple different API management instances up and running in different regions, in different lifecycle stages. So you need a solution where you can bring all of your APIs into one single place. And this is where Azure API Center comes into place. We are this one solution where you can create your own organizational inventory for API discovery, API consumption, and API design governance reasons. And we don't care, the nice thing is we don't care whatever API type you have out there. We don't care whatever API lifecycle stage you have your API out there as well, and wherever it's deployed. So what are some of the challenges? We already touched on a few that we are helping with Azure API Center. One of the big ones is definitely the inventory aspect, right? APIs are everywhere, some of them are managed, some of them are not managed. So this creates this huge API sprawl. And you as an API admin, you want to manage this. You want to have control over your API ecosystem. You want to have transparency. So first theme that we are seeing with Azure API Center. Theme number 2 is compliance. In a world where APIs are everywhere, in a world where APIs are the driver of innovation, compliance governance is becoming more and more important. So with API Center, we are introducing features around API design governance. API management is talking about API governance from a runtime perspective. Policies, we just saw the demo, putting policies on top of your runtime. API Center looks on API governance from a different angle. It's a huge buzzword, right? API governance. We are looking at API governance from an API design standpoint. And we're going to show this in a bit. And the last and not least point of this is, now we have this one inventory. We have this inventory that is hopefully compliant, and now we want to give our developers out there access to these APIs because we want to make them more efficient and we want to boost their developer velocity. So rather than me talking about a bunch of different slides, I'm going to show you what Azure API Center looks like in action. For this, I have Bruce with me today. He's one of the engineers on Azure API Center. And yeah, let's jump right into the demo. Let me not forget about the switch. And yeah.
Awesome. Thanks, Julia. So imagine I'm an ASP.NET Web API developer building out a simple weather API. I've already created a REST API specification, and as you can see here, I'm currently editing it in VS Code. And I'm currently running the project using just the VS Code terminal. So we can go ahead and view this directly in the browser and see what we have so far. And so you can see we have a Swagger UI here, so we can easily view the different endpoints that I've implemented. And so we can actually go ahead and just try one out as well. So let's go ahead and try out the city weather endpoint. And as you can see, I get back a successful response, so you can see that the API I've developed so far is working. And now going back to VS Code, once I finish developing and testing this API, I now want to register an API, so that way other developers in my org can easily discover and consume this new API I've just created. And before I even do that, I first want to see what other APIs are in my API Center instance. And for that, we have this handy VS Code extension, which is now publicly available. So if I go to the API Center VS Code extension, I can see that I can select my Azure subscription. And if I expand it, I can then see my API Center resource. And expanding that, I can see the different resources we have, which includes APIs and environments. And here we can see that we already have some APIs in my instance. So other developers have already uploaded their APIs. And now I want to register my own API. And so we can do this in two different ways. First, we can do this directly through the VS Code extension. So if we just right-click on APIs, we can go ahead and click Register API. And we have two options. We can either manually input the API details, or we can set up a CI/CD pipeline to automate the process of registration. Now, the second way I'm going to show is through Azure CLI command. Here, if I run this Azure CLI command, what it's doing is we pass in the path to our REST API specification, and this automatically generates resources. So it creates an API, API version, API definition, and it imports our specification. So now, if we refresh our VS Code extension, just like that, we can see that our new API has been uploaded, the name corresponding to the title that we have in the spec. And if we expand it, we can see as well the version that we've also specified in the spec. And so we can expand the definition to actually view the spec itself. And now we can explore different ways that developers can consume and test this API in the VS Code extension. So if we just right-click on it, we can see the different options we have available. So first, we can export the API spec document. And what this does is it allows us to view it directly in VS Code, just so we can keep up to date with the changes and see what's available. Next, we can generate an API client. And so this generates using 𝗬𝗬𝗀. And so this will take us to this prompt here. We can then select which methods we want to generate. And after we select those, then it'll ask us which programming language we want to use. And now going back to extension, the final two features we have are for testing APIs. So we can either, first, we can generate an HTTP file, or we can open API documentation. And this will open a Swagger view, just like I showed earlier in the demo. So I'm going to show the HTTP file. If I click on this, you can see it creates an HTTP client file for us. And going back to the spec real quick, you can see that we added in it a server detail, including the deployment URL. So this automatically gets populated to the spec, or the HTTP file that gets generated. And this allows us to easily test endpoints right away. So we can just, with one click, send the request. And just like that, we get back our response, so we know that it's all working. Great. So now we've shown that we've developed an API specification, we successfully registered to API Center, and we've shown how developers can discover, test, and consume these APIs. Now I'll hand it back to Julia to showcase the API admin point of view.
Awesome. Thank you, Bruce. So I'm putting my API admin hat on here by switching to the other screen. And let's look at what the Azure portal experience, the API admin experience looks like, right? So as you can see, I'm here in Azure. I have an API Center up and running. And via our APIs tab, I now have the admin view of these APIs. I can go in here. I see all of the different APIs that I have. I even see more information, right? The lifecycle type, the API type itself as well. So if I hit refresh here, it's going to show me the new API that Bruce just registered. We all know the struggle, right? Lots of APIs. A lot of APIs are probably being registered here. So it might be nice if I'm just being notified about a new API that's being registered. So for this, I'm using the events integration. And I went ahead and configured my own Logic App workflow. So now every time a new API is being registered, I'm getting a Teams message that says, hey, a new API has been registered in your API Center. It also gives me a link to my instance, so I can immediately, right from within Teams, open up my instance and check on the different APIs. I also have two action items implemented. So one is contacting the API developer, whoever that is, and also mark it as complete. So I'm not quite sure if I want to mark my API as complete. So let me go back to my API Center instance here and check out the new API. So in API Center, we have the concept of custom metadata. We do understand every organization is different, and you might want to store additional information on top of your APIs. So this is where the concept of custom metadata comes in. You can go in and you can configure as many custom metadata as you want. So additional information you want to store on top of these APIs for compliance reason, governance reason, better transparency reasons. Right now in my Azure API Center, I have two metadata configured, API approver and also compliance status. So let's take a look what this looks like from an API perspective. Let me open up the web API that Bruce just registered. And here you can find the custom metadata tab. So here again, you see the two custom metadata that I previously defined. I have a way to modify and edit these in the Azure portal or using, for example, the CLI extension as well. So there are different ways to update this information and keep your API inventory ready and always up to date. All right, so we talked about the inventory. We talked about custom metadata. What about governance, right? I mentioned this at the beginning as well. So that's where we are introducing API analysis. Again, the difference between API management is it cares about API governance from a runtime perspective. API analysis or API Center cares about API design governance. So now you have all of your APIs in one single place. Ideally, with different specifications coming up, you might have different rules, different standards across your organization that you want to make sure every time a new API comes in, they're actually following these rules. So this is where API analysis comes in. I now have a way to look at this API and see, actually the just recently registered API is not following the rules that I have configured within my organization. It shows one warning and one error message. Let's check this out in detail. So I can go and check out the API analysis report for my specific API, and I can see where I'm seeing my error message and also where I'm seeing my warning message, right? So if I scroll down, I'm even getting more information about what's happening and what the developer might want to do differently. All right, so I'm the API admin. Ideally, we want the API developer to make these changes, right? So for this, again, that's where I'm leveraging my workflow. I want to contact my API developer, so that's why I have like this really handy action implemented. So I'm going to click on here. I do remember I have one arrow and one warning. Please fix it. So now I just have to hit the send button, and let's see if Bruce is getting this information.
Thanks, Julia. And now I can open up Teams, and let's see. And now I see that in my API developers group chat, I have a new message. And this tells me right away that the API I just registered is not compliant, like Julia mentioned. And that's because it has one warning and one error. And this message also includes a link to the linting guidelines that the API admin has set up for this specific API Center instance. So I know exactly which rules I'm breaking. So if I open this link, and I can directly view in the browser, and here we can see that it's just a modified spectral file, but the admin has added a few custom rules to it that I need to abide by. And so I'm going to go ahead and copy this URL. And now let's go back to VS Code to make the necessary changes to make my API compliant. So what I can do in VS Code is I can open up the VS Code command prompt. And there's this command where I can set the active API style guide for API Center. So let's click on this. And we can input the remote URL directly here. And now let's just paste that URL. And now if we go back to our spec, we can see that it highlights exactly the lines that are not compliant. And so we exactly know where to look and how to fix it. And to make things even more convenient, in order to apply these fixes, we can go ahead and hover over the non-compliant lines. And let's fix it with Copilot. We just click Quick Fix, and then Copilot will basically automatically explain the error message and suggest a code change that'll fix it. And so you can see it tells us here that for the title, we just need to pre-append API Center to the name. And so let's go ahead and accept this. And just like that, we've already reduced one warning message. And now let's go to the error that we have. It's with version. So once again, let's fix this with Copilot. And now it explains that the API version has to follow the specific date format. And so we can go ahead and apply this as well. Now let's save these changes. And just like that, we fix all the non-compliant issues within our API spec. And now, just like before, we want to re-register this in API Center so it gets updated there. And we can do this with the CLI commands like I showed earlier. However, this time it'll be slightly different because we're not creating entirely a new API. We're just creating a new API version. Now, once we run those commands, let's go ahead and refresh the VS Code extension. Now, if we expand our API and look at the versions, we can see that the new version has just been uploaded with the new name that I added. And so we can then expand this version. And like I showed before, it'll show the API spec, and we can use all these different features to discover and consume it again. Great. So now we've made our API compliant. We've registered it. Now the only thing left to do, let's just go back to Teams and go ahead and mark the item as completed in the workflow to notify the admin.
Awesome. So perfect. Me as the API admin, I'm now being notified again that Bruce updated the API that we just saw. He has not just updated it, he actually uploaded a new API version. So let's check out the new changes that he's done. So in my API analysis tab, I now want to see the new version that Bruce uploaded here. And as you can see and tell by the different uploaded version, this time I'm not getting any error or any warning messages. So I'm able to really mark this as complete and make sure whenever this API is being consumed by our developers out there, they are aware that this is a compliant, organizational compliant API, and they should use it and can create amazing applications with it. Let me quickly recap what we saw. We saw API Center as your inventory solution, where you can register all of these APIs. We talked about the concept of custom metadata, expanding your inventory, adding additional information, whatever is a fit for you. We then also talked about API analysis from an API design governance standpoint and how you can put an extra layer of compliance on top of your APIs to make sure whoever is consuming these APIs are in a compliant state and you feel safe as an organization for these APIs to be consumed. So let's go back to the slides. As I mentioned at the beginning, Azure API Center is now generally available. Feel free anytime to reach out if you have requests, ask feature requests, or feedback for us in general. And we will be here after the session. We also have a booth up on floor 5, so always feel free to stop by and say hi to either the API management team or the Azure API Center team. We are part of the API management organization, so you will find us at their booth. And yeah, I think we have some time for some Q&A. So Nima, if you would like to come up again, whatever question you have out there, we are happy to answer these.
Are the APIs published prior to being approved by the admin?
You're talking about API Center, right?
API Center, yes.
Yeah, These are already published. So that's also one of the big differentiator between API management. API management is the gateway. We are the inventory solution. So these APIs are already published. They are already, of course, different lifecycle stages, but the developer has already published it. In our use case, it was an app service. So yeah, these are already running somewhere. The endpoints are available.
Sure. So the question is if the token counting policy works with streaming, and it does. Yes. Yes.
The semantic similarity search, what effect does it have on performance, and is it using some internal LLM embeddings?
So the question was the semantic search policy, what is the effect on performance, and what was the other one? Yes. So I probably have to explain how it works, and then we can get to your question. So the way it works is for every request, we are making a call to the back-end OpenAI to get a vector back, an embeddings vector back for the request. So that's for every call. And we are caching it. So it has slight effect on performance because of that call. But when it's successful, you saw the difference between like 2 seconds plus versus like 10 milliseconds. Does that answer the question? Okay.
The question was around automation for registering these APIs. So in our demo, we showed the API Center CLI extension. This one is out there. We are a GA product, so this one can be used as one option to automate it. We also have CI/CD support, so by using the CLI under the hood, you could set up, you can configure your own Azure DevOps pipelines items, for example, or GitHub action items. As a team, and also looking at the semester, some of the things we are working on is making it more integrated as part of the action items setup. For example, as it is right now, you can already configure it yourself just using it, but it's definitely something we are working on to make the automation process more improved. Yeah. Yeah?
I'm full of questions. In API Manager for the failover and redundancy, I couldn't help but notice that when it failed over to US East, it said token count NA. So did that request actually get rerouted, or did that request go into a black hole and the next request goes to US East?
So the question is, when they saw on the load balancer demo, when we saw the request going from one instance to the other, was there a request that just went into a black hole? And the answer is no, because we support retry. So that request was retried on the other instance, and there was no downtime. Okay, sounds like no more questions.
Yeah. As mentioned, feel free to drop by our booth. We will be there if you have any more additional questions. And yeah, thanks everyone for showing up, giving us your time.
Thank you.